Hi guys. In a previous video I showed you how to write an assembly program for reading in an unsigned integer from the keyboard character by character and how to assemble its unsigned value in some register. Now this video is about doing the opposite. We already have some unsigned value in some register and we want to print it out on the terminal. And you will see the idea for doing that is kind of similar. We just have to overcome a minor challenge, and that means I will do what a mathematician is doing in such a case. I will show you the principal idea for doing this and leave the nasty details to you as a simple exercise. Like in the last video, I will begin with a special case, again, the value 123. Now it's already stored in a register, and let's say register 1, and now I want to print out this single digits. For getting the last digit, I simply have to divide this by 10 and take the remainder. Then I already have the numerical value 3. And then in order to get its ASCII value, I just add the ASCII value of 0, of the character for 0. And after that, I can print out the last character. And then I will continue with 12. For that, I divide this value stored in register 1 by 10. This time I do an integer division. That means I truncate the result to 12. And then you already see we have here a loop. I now continue with 12 in register 1, compute the numerical value of the last digit by taking the remainder after dividing it with 10, compute its ASCII character value and print out this character, and then I continue with 1. And then last time I will compute the last digit, the numerical value, compute its ASCII code, print it out, and then you see if the division by 10 gives you 0, you are done. Then you print it out all the digits. And this of course can easily be generalized and with a loop, and you can represent this in a flowchart like here. And if you start with that, and I suggest that, you will see this almost does the job, but it is printing the digits in reverse order. But this easily can be fixed. So if this first step is implemented, tested, and is printing the unsigned integers just in reverse order, you improve your implementation or correct your implementation. And for that, you can use a buffer with 20 bytes. So you can store 20 characters in this buffer. For that, you can use some part of the data segment or BSS segment. And you will see that 20 characters will be sufficient for all the digits that you possibly could have with a 64-bit unsigned integer. And then you use a third register, which initially points to the begin of this buffer. And then instead of printing a character stored in register 2, you store this character first at the end of this pointer and then increment this pointer, this register 3. And this will be done for every character that you previously just printed. So you fill up this buffer with the single digits. And when you're done, this register 3 points to the end of this sequence of characters. And then you print out actually the characters in reverse order by doing the opposite thing. First decrementing this register, this pointer, then print out what is at the end of this pointer, and continue until you reach again the begin of this buffer. And that's it. For this exercise, you will need 2 more instructions, and you will find them on the website with some additional explanation for them. For example, this unsigned integer division is computing both the quotient and the remainder. So actually, you can save 1 instruction in this algorithm. And you will also find an instruction for storing a single byte.